Welcome back everyone to the part 2 of the trigonometry lesson, which is sum and difference identities. So what we're going to do here is we're going to answer some questions. So this is a practice video. All right, so without further ado, let's begin. So this one, sine 30 degrees plus 60 degrees. So obviously, so if you want to do it in a simple way, right, we're just going to add, this one, 60 plus 30 is 90 degrees, and sine 90 degrees is equals to 1. So that's it, that's your answer. So can we prove that sine 30 plus 60 degrees is equals to 1 also? Without, using addition, just like, adding two angles. We're just going to use sum and difference identities. The answer is yes, we can. Okay, let's have a short recall. Since the given here is a, you know, trigonometric function, which is sine, and you have two separable special angles. So what we're going to use here is sine A times cosine B, okay, cosine B, plus cosine A times sine B, okay. So why addition? Okay, the operation used here is addition because the addition used there inside is also addition, so basically a plus sign. So your A will always be on the left part. Your B will always be on the right part. So let's further substitute. This is sine 30 degrees times cosine 60 degrees plus cosine 30 degrees. Okay, hold on. Cosine 30 degrees times sine 60 degrees. Okay, so let's have a short recap. If you have a specific trigonometric function with its input is a special angle. So if we have sine 30 degrees, this is 1/2. Cosine 60 degrees, we have 1/2. Cosine 30 degrees, we have square root of 3 over 2. And oops, sorry, I was about to write sine. All right. So we have sine 60 degrees, which is square root of 3 over 2. All right, that's it. So now let's further substitute. Sine 30 degrees is equal to 1/2 times cosine 60 is 1/2 also, plus cosine 30 square root of 3 over 2 times sine 60 square root of 3 over 2. So if you're just going to multiply two fractions, what you're just going to do is just multiply the numerator to the numerator and the denominator to the denominator. So this one times 1, 1. Over 2 times 2, 4. That's it. Next. So here, okay, how about this one? What can you do? Because these two, okay, these two terms from the numerator, these are both radical terms. So radical terms, basically, it is a term that has a root and then a term within it. This term within of a root is what you call radicand, okay, radicand, okay? And then the root here is your radical sign. And overall, this is what you call a radical term. So how can you multiply this one? So as you can see, you have a square root and both of them have square roots. So they have, okay, that's good. And then the radicand, basically a term within a root, okay, is just the same as the other term. So basically 3 and 3. So what you're going to do is that we're going to cancel the roots and then copy the radical. 3. That's it. So therefore, we have 3 over 4. So now let's add the two fractions. Since these two are similar fraction, so we're just going to, copy the denominator and add the numerator terms or terms in the numerator. So 1 plus 3 is 4 over 4. And that is equal to 1. See? Now, we prove that sine 30 plus 60 is equal to 1. Sorry if I speak faster, all right? Basically, this one, the one that what I'm actually trying to explain here, like this one, okay, and this one right here, like adding similar fractions and then multiplying both radical terms. These are just actually basic. That's why I just, speak as fast as I can so that I can proceed to the next problem. All right, especially rewriting this formula. Next, cosine 90 minus 45 degrees. So again, If you're just going to find the difference of it, this would be cosine of 45 degrees, which result into square root of 2 over 2, because cosine 45 degrees is square root of 2 over 2. So can we prove it with the use of sum and difference identities? The answer is yes. So this one right here, we have a trigonometric function which is cosine. So we're going to use cosine formula in the sum and difference identities. And you have two terms, which is 1945. And then the operation used inside is subtraction. Therefore, the formula used here is cosine A times cosine B plus sine A times sine B. So again, your A is the left part and your B is on the right part. So this will be cosine 90 degrees times cosine 45 degrees plus sine 90 degrees times sine 45 degrees. So before we proceed, let's have a short recall. Cosine 90 degrees is equal to 0. Cosine 45 degrees is equals to square root of 2 over 2, which I already said it to you earlier. Then sine 90 degrees is equals to 1, and sine 45 degrees is just the same as the cosine 45 degrees, which is equals to square root of 2 over 2. Forgive my handwriting. All right, that's it. So cosine 90 degrees is 0 times cosine 45 degrees is square root of 2 over 2. Then sine 90 is 1 times sine 45 is square root of 2 over 2. So let's just multiply both sides. So this one would be 0 plus 1 times square root of 2 over 2, just square root of 2 over 2. And that's it. So we prove it via sum and difference identities. Next problem. This one. If you would recall in the part 1 of trigonometry, sum and difference identities, the introduction basically. So this one right here, it is not again a special angle. So what we can do here is that we can separate it into two special angles. So I can rewrite this one as sine of 30 degrees plus 45 degrees. Okay? Because 13, 45 plus 70 is equals to 75 degrees. So basically, in other words, okay, think of any numbers, okay, only two special angles, okay, that would result to 75 degrees, whether you add it or subtract it. So since 75 degrees is the same as 30 plus 45, so I use sine of 30 degrees plus 45 degrees. So since, again, I use sine, and the given, yeah, it is sine. So I'm going to use a formula, which is sine A times cosine B plus cosine A times sine B. So your A is again on the left side. So this would be sine 30 degrees times your cosine B, hold on, that's it, cosine B, which is cosine 45 degrees, which is on the right part, plus cosine A, so the first part, which is, or the left part, cosine 30 degrees, times sine B, which is sine 45 degrees. I don't need to recall this one because I already mentioned previously in the video that sine 30 is 1/2 times cosine 45 degrees is square root of 2 over 2 plus cosine 30 degrees is square root of 3 over 2 and sine 45 degrees is square root of 2 over 2. Okay, so now let's multiply the fraction. So 1 times 2, 1 times square root of 2 will be square root of 2. All over 2 times 2 is 4. Plus, how about this one? Okay, we have a radical term times another radical term. Okay, the similarities between the two is the root. They're both square roots. But the main difference is the radicand. Okay, 3 and 2. So what can we do about this? So just basically copy the roots, then multiply the two radicands inside of that root. And then that would be your final answer. So therefore, the square root of 3 times square root of 2 is equals to square root of 6. Okay? All over 2 times 2, 4. And again, this is just a Once again, wait, hold on, that's it. A similar fractions because they both of them have the same denominator. So I'm just going to combine them. Square root of 2 plus square root of 6 all over 4. And that is your final answer. Okay. Next, cosine 165 degrees. Okay. So I will think two special angles here. So I can think of two, and their sum would be 165 degrees, and this is 120 degrees plus 45 degrees, because 120 degrees plus 45 degrees is 165 degrees. Okay, so since the given is a cosine function, so therefore we're going to use cosine A times cosine B, and since it is addition, so we're going to subtract it, minus sine A, sine A times sine B. So again, your A is on the left side, B is on the right side. So this would be cosine 120 degrees times cosine 45 degrees. Okay, minus sine 120 degrees times sine 45 degrees. Okay, now before we proceed, we need to know what is 120 degrees, because we know that cosine 45 degrees is just the same as sine 45 degrees, which is square root of 2 over 2. How about this two? Okay, so let's rewrite. Cosine 120 degrees is equal to what? Negative 1/2. As for the sine, however, sine of 120 degrees, this is square root of 3 over 2. Okay, we call that. So now we can multiply this one. So negative 1/2 times cosine 45 degrees, which is square root of 2 over 2, minus sine 120 degrees is square root of 3 over 2. Okay, times sine 45, which is square root of 2 over 2. Okay, good. So let's multiply the fraction. So negative 1 times square root of 2. So it would be negative square root of 2 over 4 minus, again, if ever you see two radicals and then they have the same roots, it's just that their difference is their radicand. So copy the roots and multiply the two radicand. So 3 times 2, 6. That's it. All over 2 times 2, 4. So let's further combine it. We have what? Square root of 2 minus square root of 6 over 4. And this is your final answer. Okay. So bottom line, guys, it's up to you. For me, basically, I just think two numbers. Okay. Two numbers that would at least would make sense that the result would be 165 degrees. Okay. So that's why I was like, okay, so 165 degrees is just the same as 120 degrees plus 45 degrees. I just decompose them into two special angles. All right. So basically, that's the goal. So it's up to you. All right. Maybe yours is by subtracting two angles, and for me, I just basically added two angles. So again and again, it's up to you. Next problem, we have tangent 105 degrees. So tangent 105 degrees. Now I'm going to think two numbers that will result into 105 degrees. So I will use 60 degrees and 45 degrees because 60 plus 45 is 105. Therefore, I can rewrite this one into tangent of 60 degrees plus 45 degrees. Okay. Now we're going to use the formula. The formula of that would be tangent A plus tangent B all over 1 minus, okay, tangent A times tangent B. Okay, so again, your A is on the left and your B is on the right. Therefore, we have tangent 60 degrees plus tangent 45 degrees, okay, over 1 minus tangent 60 degrees, okay, times tangent 45 degrees. Okay, that's it. So before we begin, let's recall. Right? Again, let's recall. Okay. So what is tangent 60 degrees? Tangent 60 degrees is basically square root of 3. Right? Square root of 3. That's it. Okay. And when we say tangent of 45 degrees, this is 1. Exactly 1. Therefore, let's substitute. So this is square root of 3 plus 1 over 1 minus square root of 3 times 1, which result into square root of 3 plus 1 all over 1 minus square root of 3. That's it. So this could be your final answer. Why did I say could be? Because this is not yet the simplified answer, but this is still correct if you like to leave it as it is. This is still correct. So I'll make it more simplified. So how do we simplify basically a binomial? Okay, binomial is basically two terms, one a radical, one a constant. So you have two terms. Okay, so this is a binomial, especially this one, a constant and a radical. Okay, so how do we simplify a binomial in which you have a radical term? So square root of 3 and negative square root of 3 are your radical terms. So how would you simplify? So we're going to simplify by the use of rationalizing. How do you rationalize? Okay, so we're going to do this one, square root of 3 plus 1 over 1 minus square root of 3. So what to do here? Basically, okay, we're going to multiply the denominator and the numerator by its own denominator. It's just that we need to change the operation. Again. We're going to multiply the numerator and the denominator by its own denominator. It's just that we need to change the operation. Again, so let's do it slowly. Okay? We're going to multiply both sides by the denominator itself. Okay? But instead of, the operation itself is minus, we're going to use positive. That's it. Okay? Again, I'll say slowly. By rationalizing, multiply both sides, numerator and the denominator, by their own denominator, but interchange the operation. So as you see, I multiply both sides by 1 and square root of 3, but the operation used here is not subtraction, rather it's addition. And since you see this one, this 1 plus square root of 3, I can actually just rewrite this one, square root of 3 plus 1 times square root of 3 plus 1, because they're just the same, right? They're just the same. You know what I mean? Like, they have both the same sign, so we're just gonna interchange. So I'll just put square root of 3 in the first place. Just the same. So now, since these two are binomials, so that means, if I would put it in a parenthesis way, okay, I'll do the same thing as the denominator. So since their guys are both the same, and then the terms there are also the same, okay, so what happens, we're just going to combine them as a whole. Okay, so we have square root of 3 plus 1, and then since a binomial, like a simple binomial, is always raised to 1, therefore, we're going to add the exponents. 1 plus 1 would be 2. Okay? It's just like this one, like x plus y times x plus y. Alright? We're going to multiply them. And don't forget, guys, there's always an invincible exponent, which is your 1. And since you guys have the same base or the same terms inside, so this would be like x plus y raised to 2, because you're just adding the what? The two exponents. Okay, 1 plus 1. Oh, that's it. Okay. All over this one, yeah, you may guys have the same value, but different, different operations. That's why they have different terms. So we're not going to do that. Okay. We're just going to leave it as it is. So, oops, sorry, it would be plus. This would be plus. Okay. So we can expand, the numerator and the same thing as the denominator. How do we expand this one? First, the numerator. Okay, this one is a squared binomial. So how can we expand it? Obviously, we're going to use FOIL method. Okay. However, all right, there's a technique that I would like to show to you instead, and I think that would be in my opinion, the most convenient way for you to understand. So let's just say I have x plus y squared. The first step here is square the first term. So use your first term, right? Square it, raised to 2. Plus the second step, 2 times the first term and the second term, or basically your last term. You know what I mean? Okay. Then last but not the least, square the last term, this one. So square the y squared. So with further simplification, we have x squared plus 2xy plus y squared. That's it. Okay. Can we do that in the numerator? Yes, we can do that. Okay, we can. All right, let's just erase this one. Okay, hold on. That's it. Okay. So here we have your first term, square root of 3. So square the first term. Okay, so square root of 3 squared plus, okay, 2 times, okay, that's your second step. The second step is 2 times the first term. Oh, wait, why did I write, I mean, why was I about to write x? But anyways, the first term, then the second term, one, or the last term. Then square the last term. That's it. Okay, we just leave it as it is. How about for the denominator? So you see again, these guys have again the same value or number, like 1 square root of 3, 1 square root of 3. But the difference is what? The operation. This one is what? Negative square root of 3. This one is positive square root of 3. Or to put it in a different way, this is minus 3 and this one is plus 3. So the operation is different. So there's a technique here, all right? So for example, if I have x minus y times x plus y. So you see, x, y, and y, they're just the same. To be honest, they're just the same, all right? They're just the same. However, the difference is their operations. They are not the same. So what to do? You just need 2 steps. Okay, actually 3 steps. First step, square the first term. What's your first term here? Is your x, right? Your x. So square them, x squared. Then the second step, minus. Then the last step, squared the last term, y squared. That's it. So can we do it here? Yes, we can. Okay. So since we have the same number, 1 square root of 3, and same thing goes on to the other one, 1 square root of 3, it's just that the difference are their operations, which is the other is negative, the other is positive. So we're going to apply this rule. And we're going to apply this rule. Okay. So let me erase this one. Okay, hold on. So first step is you need to square the first term. So what is your first term here? Which is your 1. So square that would be 1 squared minus square the last term, which is square root of 3. Nice. Okay, that's it. And now let's go here. All right. So this one, if you're going to square a radical, okay, in which its root is also square root, then just cancel it out. Okay, like for example, I have square root of 5 squared. So this one is a square root, and then the exponent is 2. So it's like a squared of square root of 5. So cancel 5 and just copy 5. All right, that's it. Because it's just the same as just the same as the previous one, to be honest. Okay, like this one. This one is just the same as square root of 5 times square root of 5. Or since you have the same roots, so just cancel this out, then copy the radical, which is your 5. That's it. Right, that's it. So let's erase this one. And we erase this one. Okay, good. Now let's do it. So the square root of 3 is just 3. Then 2 times square root of 3 times 1 is just 2 square root of 3. Then square root of 1 is just 1. All over 1 minus square root of 3 is just 3. So let's combine all the similar terms. So we have 4 plus 2 square root of 3. Because overall 3 and 1 are the constant terms. And they don't have basically a radical term. So yeah, 3 and 1 are its whole number. Okay, and then here 1 minus 3 is just negative 2. Okay, this could be your final answer, or you can simplify it even more. So this one, this numerator, okay, this binomial, I can actually factor it out by 2 because the GCF, okay, the GCF of this binomial is 2. So I'm gonna bring out or factor out 2 outside. So this will be 2, and then this will be 2 plus square root of 3. All right, all over negative 2. So 2 divided by negative 2 is negative 1. Then 2 plus square root of 3. So the answer here is negative 2 minus square root of 3. And that is your final answer. It's long, right? But hey, trust me, it will be worth it if you keep practicing. Okay, next. Okay, this one is a bit long. All right, it's so intimidating, but to be honest, you should never intimidate. Okay, you should never intimidate. If you recall in my previous video, in the introduction, I told you you need to be familiarized, or basically, you need to know, this formula or identities. Okay, because this one will literally help you, especially if the given is this. Okay, so sin, cos, sin, and look at the numbers 15, 15, 15, 15. So meaning they're all the same. And plus, look at that one. See, do you sense something here? Do you sense something here? This is just basically, the formula of your sine in the sum and difference identities. Recall that sine A, okay, cosine B plus cosine A times sine B is equal to sine of A plus B. See? So now, look at the similarities. Okay? See? And then here, your A is what? 15. Your B is also 15. Your A is also 15 and your B is also 15. Therefore, your A is 15 and your B is 15. So to rewrite it in different version, I could rewrite this as sine of 15 degrees plus 15 degrees. So this one is equal to sine of 30 degrees. So recall again that sine 30 degrees is 1/2. And that is your final answer. See, I told you, just familiarize with your formulas. And yeah, that's it. Next, how about this one? Oh, again, do not be intimidated by this. Always look at the formula or the expression above. Okay, this one looks similar to the formula of the cosine. Cosine A times cosine B, okay, minus sine A times sine B. Okay, sine B is equals to what? Cosine of A plus B. Oh, see? Now, take a look. Okay, take a look. Cosine, cosine, check. Minus, check. Sine, check. Sine, and check. How about your A and B? Your A is 15. Your B is 30. Therefore, your A should be 15, and it's correct. It's still 15. And your B is still 30. Therefore, your A here is what? 15. And your B here is 30. Again, look at A here, B here. And therefore, if that's the case, therefore, this one should be supposed to be your A. Okay, this is your A, your A, your B, your B. So that's it. Basically, just look, base this one or use this as your guide to this expression. So A here is 15, B 30, A 15, B 30. Okay, that's it. That's enough. That's so long. So, okay, so I can rewrite this one as what? Cosine of 15 degrees plus 30 degrees. So 15 plus 30 is cosine 45 degrees. And again, cosine 45 degrees is square root of 2 over 2. And that is your final answer. And we go to the last question. Again, do not be intimidated about this. Okay, don't be. All right? Always familiarize the what? Formulas in the sum and difference identities. So this one looks familiar. All right? So if you recall, this one is what? Tangent A plus tangent B all over 1 minus tangent A times tangent B. Okay? They are what? Familiar or maybe the same. It's just that the A and B here is just different. So the A here is your 18. Your B here is 40. Okay? And your A again is 80. Then your B is 40. And this one could be rewritten as tangent of A plus B. Okay? Therefore, I can rewrite this one as what? Tangent of your A, 80 degrees. Okay. Hold on. That's it. Plus, okay, your B, 40 degrees. So by adding them up, we have tangent of 120 degrees. Okay. So tangent of 120 degrees is negative square root of 3. And that is your final answer. Okay. For those who are not familiar with tangent, they only know sine and cosine, no problem, okay? Okay. Recall that tangent theta is equals to sine theta over cosine theta. All right. So the given angle we have is tangent 120 degrees is equals to sine of 120 degrees all over cosine of 120 degrees. That's it. So sine of 120 degrees is what? Square root of 3 over 2 all over cosine of 120 degrees is what? Negative 1 over 2. So we need to simplify this one by multiply the numerator above to the denominator below and multiply the denominator above to the numerator below. So basically, you reciprocate. This one is equals to square root of 3 over 2 times, okay, just interchange, okay, put 2 above and put 1 below. Okay, that's it. Okay, so just cancel out, okay. What you have is negative square root of 3 over 1, which is just the same as negative square root of 3. That's it. Okay, so bottom line, guys, when you encounter this type of problems, all right, wherein the expression is just basically the opposite, opposite way of writing into this one, then you need to be familiarized with the given formula of sum and difference identities. Okay, because it will help you in a convenient way. Okay, I don't know to you, but for me, this one's very convenient. Okay, so that's it, guys. Okay, that's it. Okay, once again, before I end this, always familiarize with you with the formulas given, especially if, for example, what if I made this minus and then this one is plus. So obviously, I'm not going to use tangent of, A plus B. Okay? I'm not going to use that. Rather, I'm going to use what? Tangent of A minus B. Because what? If this one appears, that means this is the what? The equivalent of it. Okay? So thank you again for listening to this practice video, and I, your math angel, Vane, will always guide you in mathematics. See you!